Hi, talking to you again about chapter 8.3, unit vectors and direction angles. So here we go. What is a unit vector? A unit vector of length 1 has the same direction as a given vector. So basically we're looking at a vector and we're going to make the magnitude or the length 1, right? So how do we do that? Well, we have this vector v, and that has a little hat to it, so we call that v hat, is equal to, that unit vector is equal to the vector itself divided by the vector's magnitude. Pretty easy, right? So, or you can write it as the vector v hat, the unit vector as 1 over the magnitude of the vector times the vector itself. So, in the first system example, we have a vector v is equal to negative 2, 1. And if we look, first we want to find the magnitude. First we want to find the magnitude, and that vector v is equal to the square root of negative 2 squared plus 1 squared. Okay. So magnitude of the vector v is 4 plus 1, or the square root of 5. So now, if we go into step 2, now what we're going to do is we're going to multiply. So the v hat, remember the original equation was 1 over the magnitude of the v times the vector v. So we have the unit vector v hat is equal to 1 over the square root of 5, which was the magnitude, times the vector itself, negative 2 comma 1. So we can think of that as like distributing this through. So we end up with v hat is equal to negative 2 over root 5, comma 1 over root 5. And there you go. That's your unit vector. Now, we want to check to make sure that the length is 1. Well, how do we know it's 1? Well, we go back and take the magnitude of the vector, the unit vector. So if we take negative 2 over the square root of 5 squared plus 1 over the square root of 5 and square that, we get 4/5 plus 1/5 is equal to 5/5, or the square root of 5/5, which is square root of 1, which is 1. So yes, check, it works. All right, another way we can write vectors is in the ij method. For an example, we have a vector u is 3, 4, right? In the x direction and the y direction. So this ij comes into play when we have the vector u is equal to some x component, I, plus y in the j. Now the I and j, they're not new variables. They're just describing, are we going in the x direction or are we going in the y direction? Are we going in the I direction or are we going in the j direction? Okay. So we could rewrite 3, 4 as u is equal to 3i plus 4j. Let's look at an example of that. So here we have example, find the direction angle of the vector u that is 3i minus 4j. Change the numbers on you a little bit, but that's okay. And find a vector of magnitude 7. So now we want to make sure, can this thing have a magnitude 7 that is parallel? All unit vectors are parallel to the original vector. Whenever we make a unit vector, we're not changing the angle, we're not changing it. All we're doing is we're creating a new vector that's the unit vector, which has now a magnitude length of 1 instead of 5 or 7, whatever some scalar might be. All right, so you'll notice here's the graph, right? Here's u, 3 in the x direction, 4 in the y, negative 4 in the y direction. So here's our vector u. And so we want to find the direction angle. So if you recall, theta is equal to the inverse tangent of negative 4 over 3, which equals negative 53 degrees. Plug that in your calculator. Now, a vector of magnitude 7, all we're going to do is we're going to multiply the unit vector by 7. So it's 7 times u over the magnitude of u. So we get 7 divided by the square root, doing magnitude again, of 3 squared plus negative 4 squared. And then multiply that by the vector itself, we go back to that original system, you can be 1 over the magnitude of u times u, the vector. Now if we take this and we simplify, we get 7 over the square root of 25 times the vector, 3 over negative 4. Simplify again, square root of 25 is 5, so you get 7/5 times 3i minus 4j. And that is a vector of magnitude 7. So what do? We just simply add on to our original vector another bit, and now we have 7/5 u. And that is a vector, a unit vector, in the same direction with magnitude 7 of the original problem. Alright, hope you enjoyed. Have a great time. Look forward to seeing you tomorrow. Thanks.